Hello and welcome to lesson 23.3 in the Python tutorial series. This lesson is one that I'm always pretty excited to teach. I think it's one of the cooler things that you can do in early Python programming and really goes a long way to making some cool adventure games. Now we're definitely still in text adventure mode, but you can make much more interesting text adventures than we have in the past by using some of the techniques that we're going to be introducing in this lesson. Essentially, what we're going to do is combine comparison operators like equal to or not equal to, or if statements, and string methods to create a situation where users can type full sentence commands and our program will be able to logically interpret what they're asking us to do. We're going to do this by creating a small sample game that really has no plot line, that is more, I guess, a series of print statements that show where we would put our game content if we ever got to that point. And after this, we'll finish up with project number 5, which will be the next video, where we put the stuff to use and make an actual adventure game or a side quest of an adventure game using what we talk about in this lesson. So let's go ahead and get started with lesson 23.3, where we use string methods to create the base for a really neat adventure game. So here we are with a fresh programming window. We have Python shell open, and then we also have our test.py program open on the right. When writing an adventure game, one of the first things that I like to do is write a function to generate the user's name, or I guess get their input. What do they want to name their character? That way, as the game progresses, as a programmer, I can always refer to their character by name instead of just using generic terms. So let's define a function, and we're going to call this function getName. GetName will take no parameters because the return value is going to be based on what the user inputs while this function is running. So we'll put our comment in here. I like to do that for every function. This function will return the character's name. And this will be a pretty simple line. We'll just say their name is equal to an input function. What is your character's name? We'll use an escape sequence to move the colon to the next line, make it look a little bit more clean when it's printed over in our Python shell to the left. And then we're going to return name. That's a pretty standard setup for getting a user's name, and if we run this program right now, we'll see over in the Python shell, we now have access to our getName function, and in the variable name, we'll store getName. Of course, it's going to ask for our character's name, and let's say that our character's name is, let's go with Boris. That sounds like a good warrior name right there. So I enter Boris as my character's name. Now, when I check the variable name, I can see that I've got the character name Boris. But there's a problem with this right here. My user didn't capitalize the name Boris. That might not seem like a big deal, but if the rest of my adventure game uses proper capitalization, it'll look really strange when I refer to the character by name and his name isn't capitalized. One way that I can fix that is by using string methods. Over here, I'm getting string input from the user for the character's name. If I want to make sure that this is capitalized properly, I can add .capitalize to the end, just like we did in lesson 22.1, and that will take the entire string and make the entire string lowercase except for the first letter, which will be capitalized. Now, name will have the proper capitalization stored in it in the function, and when my function returns name, it should be properly capitalized. So let's run getName again. So we'll set name equal to getName, and just like last time, we'll do Boris in all lowercase. When I check the variable name now, I can see that the character's name was properly capitalized. In fact, this will work not only if the user has all lowercase characters, but in addition, if they have their caps locks on. If I turn caps lock on and type in Boris in all capital letters, that would look strange in the context of my game as well. But because I've added the dot capitalize to the end of my input function, see that name still gets a properly capitalized character name. So to start us off in this sample game, we've got ourselves a name generator that will adjust the user's input on the fly to make sure that they're properly capitalizing the name of their character. Now that we have the name function set up, let's go ahead and write a little bit of a loop that will run our game. So I'm going back to my programming window, and the first thing that I would want to do is get the user's name. So let's store name. We'll store in the variable name, get name. So the first thing that will happen when our program runs is it will ask for the user's name. Next, let's print a little bit of an introductory message for our user. And we'll put a \n in there to give it a new line and make sure that it's separated from asking the user for their name. And we'll welcome them to the game. So we'll say, welcome %s to the game. And then we'll replace %s with the user's name. And now we've got a little bit of an introduction ready for our players. And let's go ahead and test that and make sure it's running. So let's go ahead and enter Boris as the name. We can see that now in context, Boris is capitalized correctly. The next thing I'm going to want to do is put my program into a loop that I'll break when the user quits. To do this, I'm just going to say while true. Now, there's many different ways to do this. You could set a variable like we've done in the past to is running, set it equal to true. For this little example right here, I'm going to want my while loop just to run for all of eternity until I give it a break command. So while true, this will run over and over and over. I'm going to constantly ask my player what I want them to do. So the user's response will be equal to the input function, what do you want to do? And put the colon on the next line. And so now over and over and over, the user will constantly be asked what action they want to take. When I run this program, I'll still get the enter your name function run. It'll welcome me to the game and then ask me what I want to do. And right now there's not a whole lot that I can do. In fact, there's nothing I can do. I can type in look around, I can type in quit game, eat apple. The game doesn't really respond to anything because the only instruction it has is to keep asking me for a response and then does nothing with the response. But now that we have a user's response, we can start doing some creative things with what the user enters, start looking through it for useful data, and try and figure out what was the user asking us to do. One of the first things that I'm going to want my program to be able to do is recognize when the user wants to quit. Let's start by adding an if statement. If the response, what we're really looking for is, did the user type quit? But we don't know if the user is going to type quit game, quit playing, or quit by itself. We want to see if the word quit shows up anywhere in what our user has typed. We can, using the find command that we talked about in lesson 22.1, we can do that. So if we say response.find, and we're going to look for the word quit. Remember that if the word quit is found, it will return the index value of the word quit. If quit isn't found in the user string, it will return a value of -1. So I know if the value of this if statement, or response.find, is equal to -1, then the word quit was not found in their statement. If it's any other value other than -1, then I know the word quit was found. It doesn't matter whether it's at index location 0, in the case of, say, quit game, where quit would be found as the first word, or if the user types, I want to quit the game, and then quit gets found, say, at index location 15 or index location 20, I know if the value isn't -1, the user did type quit into their game. So our check, if that returns true, we know the user typed quit. If the user typed quit, I can print, thank you for playing. Then I can break my loop and the game will be over. There's also one little change that I want to make to the way this is set up as well. Remember, our user might have the caps lock key on. In order to make sure that I'm checking for a lowercase quit, I'm going to add lower to the response. Then if the user has their caps lock key on and they type quit, it will first make it all lowercase before trying to find a lowercase quit in their string. Let's test this out and see how it works. So the user enters their name. It asks what we want to do, and right now there isn't anything we can do other than quit. But with each of these checks right here, Python is going through the string and looking for the value quit. It's not finding it, so it's returning a value of -1, so this if statement is not executing. But if I type quit game, find.quit, or the .find quit, is finding a quit word at index location 0. Since the index location is 0, the statement is not equal to -1, and it's executing. This works just as well if I were to type in, I want to quit this game. The index location isn't 0 here, it's probably somewhere between 10 and 15, but the word quit is still found in this string. So when I run find quit, I'm getting a value other than -1, and the quit routine is still running. Now we're going to use the same concept to add sort of a dictionary of words that our program is able to find. So in adventure games, one of the other common user inputs that you receive is to look, to either look at something specific or to look around. So let's add that to the dictionary of words that our program knows how to respond to. So we'll do this by adding an elif statement, the response.lower.find, and in this case we're going to look and see, did the user type in the word look? Just like we did for quit, we know the user typed look if the value is not equal to -1. One thing to note about the way this is set up is quit has a higher priority than look. If by chance the user were to type in 2 words that are both in our dictionary, our program would really only be able to handle the first word. So in this case, quit looking would cause the program to quit as opposed to look. At any rate, if the user types in look, let's go ahead and print user typed in look. Now later we'd want to go back and add that line or have that line adjusted to be in the context of our program, but for testing purposes right now we just want to know that we did identify that the user typed in look. When I run this program now, we'll enter our character's name, and now if I type in look around, we can see that our program correctly identifies that the user typed in look. Start looking at something. Because the word look shows up in that string, our program will again be able to identify that the word look was typed in. In essence, we've added look to our dictionary. One thing that I don't like that our program is doing right now is it all kind of is mashed together. In order to give the program a little bit of a break, I'm going to add \n to the front end of our response so that there's always a line break between asking the user what they want to do and the previous message. But we're not quite done yet. We need to differentiate between the different things that a user could look at. Well, if this if statement executes, we know we found the word look. We can now add some words to our dictionary that would denote maybe some of the things that the user could be looking at. For example, if I said if response.lower.find, and we'll find something that the user could look at. Let's say tree. There's a tree in our scene. We add the not equal to -1 to identify that tree was in the sentence. And then we'll print user typed in look, then tree. This if statement will only execute if the word look was found first. But because response.lower.find isn't changing the contents of the user's response, we can look through it multiple times. We could also say else print user typed in look, but we're not sure at what. So if the user typed in look, this will execute. If they type look at the tree, then we know they typed in look and then tree. If they type in look at anything else, we're not sure what they're looking at because we haven't added that word to our dictionary yet. So the user did type in look and we identified that, but we don't know what they're looking at. And later we can go back and add an appropriate message for that. So let's test the code as it stands now and see how our look command is coming along. So we type in the user's name. What do we want to do? Well, right now if I type in eat, pull, push, none of that has any sort of response. But if I type in look, I can see that the user typed in look, and they typed in look, but we're not sure what they're looking at. But if I were to type in look at the tree in the distance, the program identifies first that the word look was identified and then goes into this routine to look for what the user is looking at. It searches again and finds the word tree and then makes the reasonable assumption that our user was asking us to look at a tree. It doesn't matter what order the words come in as long as look and tree are both in the user's response. So I could say, take a look at the tree over there. It will first look for the word look, identify it, then run the series of if statements that are tied to the word look, find the word tree, and give me the same response. By doing this, I can create a whole dictionary of words that the user could look at and then put an appropriate response where these print statements go. If I add other words, I can just use response.lower.find, and then as the argument, put the word that I'm looking for, perhaps eat. If that value is not equal to -1, we know the word eat shows up, and we could print the user typed in eat. Very simply, we've just added a new word for our program to identify. Another thing that I might want to do is else add in a print statement that says no usable command was found. If this entire loop runs through every word it knows, at this point quit, look, and eat, and finds that the user didn't type in any of that, we can now print off an appropriate message saying that we know the user typed in something, but we're not able to discern what it is. With those lines in, let's run it again and see what we've got. So what is our character's name? What do we want to do? We want to look. Hey, we're not sure what we're looking at. Let's look at the tree. And you can see we've got look and tree. Then we're going to type in eat. And we've identified that the user typed in eat. If they were to type push the lever, no usable command was found. Now, if I want the user to be able to push a lever, I need to add the lines of code in here that allow it to find the word push and then allow it to find the word lever. And just like at the very beginning, if the user types quit game, it identifies the word quit and causes the loop to stop running. So we're not quite done yet with this sample program. I want to introduce variables and having the program react differently to different stages of the game. These are techniques you would use maybe if a user is walking around a map, or if you want actions to occur in a certain order. For example, there's a treasure chest and you want the treasure chest to be able to be opened, but only if the user has a key. So we're going to continue developing this sample game before moving on to our 5th project, which is a side quest in an adventure game. So thank you so much for watching lesson 22.3, using these advanced string methods to create an adventure game. We're going to continue where we left off in lesson 22.4, and then use these techniques to write the most advanced adventure game that we have thus far. As always, if you have any questions, if something is not working for you, or you need help with code that you're working on, leave those questions in the comments, and I can help you out and make sure that you're able to write the programs that you want. Until next time, thank you so much for watching, and have a great day.